Hi everybody, Mrs. Mancuso with some more Regents Chemistry Review. Now we want to go through acids and bases. And so acids always have one definition, no matter if they are an Arrhenius acid or if they are a Bronsted-Lowry acid. They are always proton donors. And a proton is an H+. So that is the definition of an acid. A base has two different definitions. If it is an Arrhenius base, it is a OH-, so a hydroxide donor. If it is instead a Bronsted-Lowry base, it is a proton acceptor. So let's think about a pH scale. Here's my pH scale. 7 in the middle is neutral. 0 on this end is the strongest acid, and 14 on this end is the strongest base. As you progress this direction, the concentration of H+ increases, and if you go this direction, the concentration of hydroxide, OH- increases. And in the middle, if you think about water as being in the middle, the H+ and the OH- are equal. So the concentration of H's and OH's. And what makes up water? HOH. So H2O is a perfect 7 because you have an exact same amount of H+ and OH-. For each step on the pH scale, you are going to increase the concentration of H+ by a factor of 10. So if I go from a 7 to a 6, I have 10 times more H+. If I go to a 5, I have 10 times 10. That is 100 times more than 7. All right, so that's how the pH scale works, and it also makes these definitions make sense. An acid adds H+, so it goes further down the scale, and a base either adds OH's so that it goes up the scale, or it takes away H+. And if you take away H+, you're going to be going this direction. So this is the acid end, this is the base end. If you have something beneath 7, it is an acid. If it is over 7, it is a base. Other things about acids and bases. Let's grab table M. So table M shows us indicators that we use when looking at an acid or a base. So the way that table M works, I could have a solution and I'm trying to find out what its pH is. So let's say I have this solution and I add methyl orange to it and it's coming out red. I look over here, red is 3.1 and lower. So I know the pH is less than 3.1. If instead I used litmus on a different solution and it has a pH of 6, I could say, all right, pH of 6 is falling in the middle here. So I go to the middle of these colors. Red and blue, a mixture of red and blue would be purple. So I would expect a pH of 6 to be purple. So that is how you use table M. All right, and then the last thing I want to do with acids and bases are neutralization reactions. So when you neutralize something, you are taking an acid plus a base. When neutralizing, you always have the same two types of products. You're always going to make some ionic compound, we call that a salt, and water, H2O. So let's try some acids and bases. We can go to table K. Here are some common acids. So let's use H2SO4. That can be our acid, H2SO4. And then our base, we can go over here, find a base, calcium hydroxide, CaOH2. What we would make, calcium and sulfate would come together. So CaSO4, this was a +2, this was a -2, those charges cancel out. So there's our salt, calcium sulfate. And then water would be our other product. The H and the OH would come together. And to balance this out, I would need 2 of these because I have 2 H's here and 2 H's here. So I need 4 H's on this side and 2 O's and 2 O's. So now I am all balanced. This is a neutralization reaction. So putting together an acid and a base, you should come out with a more neutral pH. Unless one of your acids is really strong or your base is really strong, it should neutralize it. When you want to calculate concentrations, you use the formula MAVA equals MBVB. And you get that right on the back on table T. It says titration. So when you do a titration, sorry about that, when you do a titration, you are doing a reaction between an acid and a base. So you're doing a neutralization reaction. MA is the molarity of my acid, VA is the volume of my acid, MB is the molarity of my base, and VB is the volume of my base. So I could do a reaction like we did in lab. So in the lab, you had an Erlenmeyer flask, and in here you had an acid. You used vinegar. And you put an indicator in here. You used phenolphthalein, which is clear until it turns a base and then it becomes pink. And we had a little syringe up here, and you knew the volume that you were using. So you recorded where you started. And this was 1 molar sodium hydroxide. And so you let this drip in until the indicator changed colors. When it changed colors, you recorded the final volume. So if you knew the starting volume and the final volume, you knew the volume of NaOH that you used just by subtracting. So we were trying to find the molarity of the acid. So I'm going to write Ma, because that's my unknown. Let's say I had 25 milliliters of vinegar, and then the molarity of my base is 1.0. And let's say that I used 6 milliliters of the sodium hydroxide. So you grab a calculator and you are going to solve. So divide this side by 25, divide this side by 25, 6 divided by 25. I would get the molarity of my acid is equal to 0.24 m, 24 molar. So that is how you do a neutralization reaction, and that is how you calculate the molarity of the acid. No matter what you're looking for, there's just always going to be one X, and you're going to solve for it.